This is what we covered. It's called potential distribution over a string of suspension insulators. I hope you know mass suspension insulators, one of the type of the insulators. So we covered that introduction, but I will dwell much on the calculations. This introduction, I think you can understand. So that's an example of a cross sum and a pole on which disk insulators are suspended. So that setup is what we call a string of insulators. So it is believed that along with it there is voltage distributed along with those insulators. Down there we have a line conductor, so it's distributed on the D, C, B, and the A. Yeah. So in normal circumstances, that voltages were supposed to be equal, but it is not equal due to some circumstances. Yeah, so that's just indicating, it, I think, voltage levels and number of discs you apply. And, those are stories explaining the same. And that's a representation of that, of this one. Yeah, of this diagram. This disc insulators are represented as capacitors. That capacitor is called the mutual capacitors. And between this insulator and the pole, earthly pole, there is also some sort of capacitance. That's what we call a shunt capacitance. So these capacitors are equal, and those shunt capacitors are equal as well. So we are saying that the voltage up and there see makayofanana because of these capacitors. So I'll show you now the representation of this circuit. So that's the representation of circuit. That's disk yamba disk actually yachitatu 4. So through this, that disk is represented by this capacitor. The capacitor is the same, and we have capacitor minimum energy between the disk and the pole, earthly pole. So that's the capacitance indicated as C1. Yeah. We are having voltage conductor to the highest voltage is there, so current flows upwards. So it goes there, then another side. There, that side, there, that side, there, that side. Yeah, so pali my analysis, I mean it will voltage V1, V2, V3, and V4. And it will voltage to efficiency. Yeah, shortly, I think I'll show you how we derive those formulas. Yeah, so that's the story. I think you have the notes, so you'll be able to read. So string efficiency, we calculate the efficiency of the string suspended insulators. We know that we can get the efficiency. So that is achieved by voltage across the string. That's that voltage across the string is V1 plus V2 plus V3 plus V4. So that's voltage across the string. And we have N here, and we have voltage across the lowermost unit. So N is the number of discs. So N in this case will be 1, 2, 3, 4. Yeah, and the most voltage, the voltage at the most lower part, it's this voltage V4. So when we find my voltage, when you find them, divide by number 4, this can fall in this case 4 times V4. So that will give us efficiency, that ratio. Yeah, so I think for the meantime, that's that. Then I will go through the calculations, derivations that we use to find V1, V2, 3, and quinoa. Yes.